I just wanted to let you know that the presentation we'll be working from is available for download on my website, which is streaminglearningcenter.com. And you'll have to navigate through multiple pictures of me, and I apologize for that. But your reward, if you scroll down to the learning section, will be this document here. And this document, if you scroll down there, has the PDF that we'll be talking from. So you can download it on my site, streaminglearningcenter.com, and it'll be here, tomorrow, next week, whenever. So don't feel you need to get it this very second. How to build your own cloud encoder with FFMPEG. I'm Jan Ozer. On my left, June Heider. He's with RealEyes, and David Hassoun. He's the CEO, president, whatever, of RealEyes. RealEyes is a consultancy. I'm a writer for Streaming Media Magazine, and it's kind of a good blend because, I do a lot of consulting work, so, everything I've learned gets put to good use. But these guys do high volume consulting work for big clients like I'm sure they'll tell you about. So, I'm going to cover the FFmpeg basics, and then they're going to go and tell you how to automate that, how to put it in the cloud, and how to really make it work at a high level. So who's this presentation for? It's going to go pretty quickly. We assume you have lots of video to transcode. You're using an ABR technology, either Dash or HLS. You're familiar with concepts like codecs and packaging. You know how to work with the command line and also JavaScript to a lesser degree, and you understand some basics of servers and how to work with them. So if this doesn't describe you, then it could get a little bit complicated. We did this class. We did this class last. Was it here? I guess it was here. We did this class last year, and basically what I did with the materials that I produced for the class was I wrote a book. So it's a 120-page book. It's available on Amazon in hard copy. It's available as a PDF as well. If you buy it within the next 15 days and email me the receipt, I'll send you a free copy of the PDF. So that's a $24.95 value. This only covers the FFmpeg stuff. So it covers what I'm going to cover. It does not cover any of the automation stuff they're going to be talking about. So, be advised. There is a free chapter you can download. I'll get to that at the end of my presentation. It's the chapter on HEVC encoding. So you'll see a URL for that when I get there. FFmpeg is a very complex and complicated program, and there's multiple ways to do everything. And what I tried to do was find the simplest way that I could find to make it work, but I'm not saying mine is the only way or even the best way. I'm saying what I'm going to show you works, and it works well. So we're showing the minimum commands necessary. There's a lot more configuration options that you may or may not choose to use. Just as a general rule, the location of the configuration option in the command line structure doesn't matter. If you don't choose a configuration option, FFmpeg uses the default, and that is a big deal, and you'll see why in a second. If you configure in the command line, that's going to override any default, and you'll see what I mean in a second. So this is the basic FFmpeg command script. So it's the command line. You run FFmpeg. -I is the input file. -C:\v is the codec. In this case, it's x.264. And the output file is tos.mp4. So this input file is a 1080p file in MOV format. When you do a script like this in FFmpeg, this means that you accept all the FFmpeg-based defaults. So this works well if you're doing for home movies, but this is what we end up with from a file perspective. So we get a data rate of 15 megabits per second. Why? Because we didn't specify the data rate in this command string. We get a keyframe interval of 250. That's not acceptable for adaptive bitrate streaming. You get scene change detection. So there are keyframes and scene changes. Again, that may or may not be acceptable for ABR distribution. So basically what we're going to be going through this presentation is all the stuff you have to do to customize your command lines to get to something you can do for you can produce and use as an ABR file, and then we'll hand it off to these guys, and they'll show you how to package it and distribute it in an automated way. But it's very important to know that if you use a simple command, FFmpeg will apply a lot of defaults, some of which may work fine for a file that you're encoding for disk-based playback, but won't work for ABR. So the first thing I want to focus on is bitrate control. And to measure bitrate control, I created a synthetic file that had 30 seconds of talking head and 30 seconds of ballet. So it's 30 seconds of very low motion, 30 seconds of very high motion. And if you use the, if you just select B:V for bitrate, you're setting the bitrate to 5 megabits per second, but you can see there's no data rate control in the file. So this is a program called Bitrate Viewer, and that shows the average data rate and the GOP sizes of each GOP in the file. So what you're seeing is a data rate that goes like this, and that can be problematic if you're creating a file for streaming distribution, particularly at the mobile data rate. So B:V is a pretty simple way to set the bit rate, but it's not effective for streaming distribution. To get to a mechanism you can use for streaming distribution, you need a 2-pass command line. So what we see here is FFmpeg-Y. So what -Y does is it overwrites the existing log file. And you want to put that in there because you'll be creating multiple FFmpeg encodes in the same directory, and if you don't put it in there, FFmpeg will stop and ask you each time, do you want to overwrite the log file? And then, again, we see the input file as test 1080p MOV. We're using the X.264 codec. We're doing B/V for data rate of 5 megabits per second, and we're telling FFmpeg it's pass 1. And if you have 2-pass encoding, you have to put the format you're encoding to in the first pass, and that's -F MP4. We're creating an MP4 file. And then you need to put null, the ampersand, and the slash, otherwise it just stops. So not really sure why that's in there. I'm sure, Robert, do you know why? Is it just?
The slash lets you put it on the second line.
Okay, so it's, and then the second line is basically the same thing. We're just saying pass 2. So we're telling it it's pass 2, and we're naming the output file. In this case, we're calling it 2pass.mp4. So what does this file look like? Again, bitrate viewer. The file on the left is the 2-pass encode. The file on the right is the single-pass encode. And a little bit hard to see. You can see it on the downloadable PDF. The average data rate here is 5062 or 5 megabits, 62 kilobits. And over there, it's 5007. So it's a little bit more accurate. It's not dramatically accurate. It's probably not something you really care about. But we see we still have the big peaks in the file. So we haven't cured the problem that we wanted to cure. We just had a more accurate data rate. So how do we create a CBR file? If you create a CBR file, you use 2 additional commands. You use max rate, and then you use buff size. And you only have to include these in the second line. You don't have to include them in the first line. And what the max rate does is it tells FFmpeg, create a 5 megabit per second file, but make sure the maximum rate in that file is 5 megabits a second. And then the buff size sets the VBB buffer, which also controls variability within the file. So what does that file look like? We go from this to that. So we have a file that's obviously much more consistent in terms of bit rate, a file that's going to be much easier to distribute. And remember, this is 30 seconds of talking head, 30 seconds of high motion. So that's a pretty easy file to distribute on the extreme left. You're never going to get a total flat line. It's never going to be totally flat. Here the peak rate is 5295, which is probably as close to CBR as you're going to get with most FFmpeg encodes. And the big problem I have with CBR files like this is sometimes you can have transient quality issues. And so what we're seeing here is on the left, we've got a CBR encoded file, 1080p, 2.5 megabits per second. On the right, we have the same frame encoded VBR, same target data rate. So I don't recommend CBR because you can have transient quality issues with some of your encodes. What I recommend is 110% constrained VBR. And when you use 110% constrained, you're basically saying, and it's the third line down, it's the maximum rate is 5.5 megabits per second rather than the 5 we had for CBR, or the 10 we have for 200% constrained VBR. So when you apply a constraint, you're basically telling the encoder, don't go higher than this bit rate. And this file over here is the 200% constrained VBR. We have the same problem as we had before. Here's the CBR file. And then here's the 110% constrained VBR file on the left, and here's the CBR file again. So I recommend using, with my encodes, particularly for adaptive bit rate, 110% constrained VBR, and you do it again by specifying a max rate of 110% of the target bit rate, and I pretty much always use a buffer size of the same as the data rate, again to constrain stream variability. And if you came in late, go to my website, streaminglearningcenter.com, and you can download this right now. Okay, if you're producing videos for AVR streaming, you really need to control your keyframe interval. These are the default settings. If you do nothing, these are the settings you get. You get a gop size of 250 frames, you get a keyframe minimum interval of 25, and then you get a scene change threshold of 40, and that's the sensitivity to scene change. So if you do nothing, that's what you get. If you put these in the command string, that's what you get as well. But you don't have to, obviously, because that's what FFMPEG will do if you don't. So this is what the file looks like. This is a program called Telestream Switch, and the cool thing about Telestream Switch is that you can see the iframes are yellow, the P frames are purple, and the B frames are blue. So it's even color-coded. So what you see here is a file that is not going to be acceptable for AVR delivery because the keyframes aren't at regular intervals. We've got scene change detection, and we're inserting a keyframe at those scene changes. So what do you do to fix that? What you do, and this is typically what I do, is I use a keyframe interval of either 2 or 3 seconds. Usually it's 2. I had all these cute switch graphics, and I didn't want to go back and change them, so that's why I'm using 3. But so what you do in FFmpeg is you say gop size of 3, in this case it's frames, so you say gop size of 72 for a 24 frame per second file. Keyframe interval minimum 72, which basically says I don't want any keyframes between the 72 frames that I'm designating for the keyframe interval. And you set the scene change threshold to 0, which means, even if you could put any in, I don't want you to put any scene change detected keyframes. And you need to include these in both pass 1 and pass 2. And now here's what the file looks like. So we see a keyframe all the way to the left. We see a keyframe here, 72 frames later. And you probably can't see this. You can see it on the downloadable PDF, but it says 72 here, 72 there, and 72 here. So we've accomplished our goal of getting regular keyframe intervals with no scene changes. Now, this is the syntax you would use if you want to force a keyframe every 3 seconds as opposed to doing it by frames. And what we're doing with this forced language is we're basically saying even if you insert a keyframe because of a scene change, you should insert a keyframe every 72 frames every 3 seconds. Does that make sense? So here what we're telling FFmpeg is, go ahead and insert the keyframes at scene changes, use the scene change threshold of 40, but make sure you put a keyframe every 3 seconds. And what do we accomplish there? We accomplish the regular keyframe interval at 72 frames and keyframes at scene changes, which supposedly delivers better quality. How much better quality? With this particular file, which was a 2-minute file, I think it was the Zoolander file, if you used a static keyframe interval of 3 seconds without scene changes, your PSNR for the entire file was 41.2207. If you inserted keyframes at scene changes, you increase the quality by 0.08, which is obviously insignificant. So whenever I produce with FFMPEG, if I'm producing for ABR, I don't worry about scene change. I don't worry about inserting keyframes at scene changes. I just force the 2-second interval in most cases. Does that make sense? Resolution, there's a couple of ways to do it. The simple way is with the -S, and basically that tells FFmpeg to convert your video to 1280 by 720. I only use that approach when I'm outputting the same aspect ratio as the source video. So if I have a 1080p file and I want to output at 720p, you can use the -S. If you're working with a 4K file that doesn't have a perfect 16:9 aspect ratio, I recommend using this control, because what you're getting is you're specifying the width in this case, and then it's automatically figuring out the height. If you use the -S command and you change the aspect ratio, you typically don't get the 1280/720 you asked for. FFmpeg will preserve the aspect ratio and adjust either the width or the height to compute the output file. So same aspect ratio, use the command on the left. Changing the aspect ratio, use the command on the right.
In one of the previous slides, why have you used the minimum key interval as 25?
I'm sorry, say that again.
In your previous slides, you had mentioned you had used key interval as 25 when you were setting the 3-second keyframes. So why did you do that?
The 25?
Yeah.
The 25 is the minimum, that's the default value for the minimum keyframe interval. So what I was just showing there was, go ahead and you're telling FFmpeg it's okay to insert keyframes at scene changes, and then, but maintain the 25 minimum. So use the default. And really, I didn't have to put that in, because if I didn't put it in, FFmpeg would use that anyway. Frame rate's a simple one. -R, insert your target. If you're specifying the profile and level, these are pretty simple ones as well. Just profile V for video, baseline, main, or high. Obviously, we're talking about the H.264 here, and level is the command structure on the right. That's pretty straightforward. And same deal with tuning. If you want to, FFmpeg uses X.264 and X.265. You control a lot of different parameters. We'll see what those are in a second, using different presets. And you can also tune, although I don't typically recommend tuning. Robert, do you tune at all?
Very rarely.
Do you guys tune?
Not usually, unless there's a specific
I
use
don't.
case.
Sometimes if I'm playing with animations, I'll try it, but I don't see a significant difference. So I typically don't use tuning. The preset, this is all the individual configuration options that are controlled via the presets. If you don't specify a preset, the medium preset is used, and from my perspective, medium generally does a pretty good job. I see companies going as slow as, or moving to the slower, but typically not very slow, and never use placebo, because the advantages of it are negligible, and the encoding time really, really gets high and up there. And then if you don't do anything, if you don't specify audio, FFmpeg seems to output 128 kilobits per second audio with the same channels and the same sample rate as the input file. If you want to change the audio in any way, you specify the codec, you specify the bitrate channels and sample rate as you see there. And if you're encoding multiple ABR streams, it's much more efficient to run first pass once, and then you can apply that to multiple encodes. And which configuration options must be in the first pass? The frame settings, the target data rate. Some say the audio settings, but I haven't found that to be true. So what we're seeing here, I've got one pass 1, and then I've got pass 2, pass 2, pass 2, one to create a 360p file, one to create a 720p file, and one to create a 1080p file. So the first pass is a little bit shorter than the second pass, but it's still time consuming, so it's pretty useful to use this. Interesting question, which configuration do you put in the first pass? Because you need to specify a bit rate, you need to specify a B-frame strategy, you need to specify a resolution. And we've got 3 output files here, so which parameters are going to use up here? To kind of understand that, I did 3 sets of multi-pass encodes. And the pass on the left used the 1080p parameters in the pass 1. The one in the middle used 720p parameters in pass 1. And the one on the right used the 360p parameters in pass 1. And then I measured PSNR of all 3 files. And it turned out if you use, in this case, the lowest quality file in the first pass, you got the overall highest results. You're not seeing a huge amount of difference between these 3. Typically what I do when I'm creating multi-pass encodes from a single first pass is I just use the middle file. I don't use the highest quality one, I don't use the lowest quality one. But you need parameters you need the data rate, you need the resolution in the first one. I typically use the middle file. And it does make a difference in terms of overall quality. Here's the command structure for HLS. These gentlemen will be going into another product that can do it a bit more effectively. But if you're using FFmpeg to create your output transport stream files and your variant playlist, this is what you have to do to specify it. What we see here is this is going to be in the first and the second pass, so the format is HLS. The segment length, which is critical, Apple now recommends a 6-second segment length. So we're saying it's 6 seconds. How many segments do you want in the playlist? This is a VOD encode. If you put 0, it puts all of them in there, which is what you want. And then HLS flags controls whether you create multiple output files, transport streams, or one file where you grab byte range requests within that file. So if you want byte range requests for a single file, that's what I like doing when I know it's not going to cause compatibility issues. This is the command structure to make that happen.
Does FFmpeg generate FFMP4 today?
Say it again?
Does FFmpeg generate FFMP4 today?
I think it does.
Yeah, I'm pretty sure.
Yeah, Phil, FFmpeg will do fragmented MP4 right now, correct? Yeah,
Yeah, because we tried that. We did it with HEVC.
right. Yeah. We're going to talk about Bento 4 a little bit. That's what we use mostly when we're dealing with fragmented MP4, though.
Okay. These are the HLS encoding specs. These are updated from the Apple specifications. And what's interesting is we had a class yesterday on HEVC. We didn't discuss HDR, but they've gone a lot further with HLS just in the last few months. And then here's the command structure we'd use for the first 3 files in this encoding ladder. So this is the pass 1, and this incorporates all the HLS instruction and all the other instruction that we covered in the class previously. And I'm running way over my time, so I'm kind of, if you're encoding HEVC, anybody looking to include HEVC in their HLS encodes? This is the downloadable chapter for my book, and this will tell you how basically you need to use a completely different structure for a lot of the X.265 commands that preceded by the X.265 params that you see in bold. And again, if you're going to be doing HEVC, I recommend downloading the chapter. It is free, and it's going to cover this in a lot more detail. That's my
You good? Thank you, Jen.
All right, so once again, my name is David Hassoun. I'm the founder and CEO over at RealEyes. We've been in business about 14 years, and we do a whole bunch with video. We have a number of customers, NBC Sports, Viacom, Oracle, US government. We've helped put together some pretty cool video solutions over time, everything from video player development, media workflow, and kind of bringing those pieces together. So we're going to show you a few things, carrying on from what Jan did. One is starting off with some other tools, including Bento 4. We're going to talk a little bit about that. And then we're going to go through a little bit about what are the considerations you need to take if you guys are trying to put together a custom cloud encoder. There are great services out there. Amazon has tons, Elemental. There's a number of them they can do, and they have great functionality. But there's also a lot of this that you might need custom level management, stitching of your content, or other factors, including just cost and management. And those can be some of the factors that you want to consider. Okay, well, hey, there's these really cool tools. Why can't we just build something to kind of help manage those to meet our needs? So that's what we're going to talk through on this rest of this. And we have a little demo. We also built a kind of a baseline little cloud encoder app that we share with you guys. You guys get all the source code to it. We'll take a peek at that working and talk a little bit through it. And at the end, we might show you another little tool that we have that we're going to be open sourcing here soon for kind of looking at monitoring manifests. So first off, has anyone here used Bento 4? Nice, at least a few guys. For those of you guys who haven't, you guys used FFmpeg? More hands? About the same hands, and then some? Cool. Bento 4 is really neat. We started using it for some production work in the last year. And it's been really, really valuable to us. It's not necessarily a replacement for FFmpeg, although it can replace some of the processing that we do there. It's generally used for managing packaging content for HLS or Dash, and works all around MP4 files. You give it MP4 files, it gives you back content that's ready to be distributed. It can do a lot more stuff, and pretty fast, than FFmpeg in that area. Other areas it's going to be lacking, which we'll kind of go through there. But you can do everything from parsing, multiplexing, H.264, H2 streams, supporting DRM for modeling, play rate, wideband, fair play. Works with H.264 and 265 and all the appropriate audio formats. And it's really good at doing both Dash and HLS right out of the gate. And that's really cool if you're working with fragmented MP4. The idea here is that you can have the same bits, but presented in two different manifests and be able to roll those out much quicker and cleaner in the past. Also things with atom box editing, stream codec information, pulling all your bit rates together, and also generating your master manifest, something else that was kind of a lack in other areas with FFmpeg at times. So Bento 4 at a high level focuses on MP4-based content, packaging, and transmuxing. FFmpeg can do some of that, but it's has a much broader spectrum of tools, specifically around encoding, conversion, and some level of packaging. So nowadays we use FFmpeg when we have to do transcode, take something into an MP4 base, and then we use Bento for when we actually have to package that out for delivery. Generally speaking, it runs a lot faster, has really good features, and works quite well, and has been a really good pairing for us in the past with what we had to do with FFmpeg. Before, we had to do a lot more kind of manipulations at manifest level and so forth manually, and we're able to kind of bypass some of that stuff now. So as I mentioned, you can do things like master playlist generation, single file output with byte range requests automatically managed for us, iframe only playlists, AES encryption, DRM, audio stream sidecar, subtitle sidecar, as well as handling all the FMP4 stuff, which is where we're really focused on really moving towards as things continue. We are strong believers in getting away from TS-based, going to fragment MP4 and CMAF, and seeing how that can be really beneficial to our customers down the road. So working with Bento, I'm going to zip through these a little bit fast. We just wanted to give you guys a few commands, show you how they kind of work, and what you get out of it. Generally speaking, you get a lot output from little input in Bento to a large degree, and it works pretty well. So here we're specifying, hey, we want to do an MP4 HLS. We're going to give it a version of 4. We're going to specify our input files for a 7.5 and 3.5 megabit. And our output will automatically give us a master M3U8 linking up our multiple variants. So we get a stream M3U8 for each bit rate, all 3 of them. An iframe for the M3U8 for each bit rate. So that's for our trick playback and thumbnail type stuff. And then TS fragments for each bit rate. If we want to work with multiple audio streams, we can manage that in a couple of different ways. We can specify whether or not we want to do language tags. There's just going to be default audio, and it will automatically manage generating out the M308s and the fragments and AAC fragments out of those for those, putting those together in our master manifest for us for multi-audio management. WebVTT, something similar as well. We just specify, hey, we want to do a WebVTT, specify the language, and the output, we'll be able to get that as well. Encryption and single segment. So this has shown us both how to do a byte range as well as doing encryption in here. So once again, HLS version 4, we're going to specify output single file. That's going to manage sort of doing the bit range stuff for us from a single segment. Segment duration, we can specify that. Obviously, key thing there is you want to make sure that you align that to your keyframe interval. What encryption mode, what encryption key, and of course then the output. And then this will give us pretty much everything that we'd want out of that pretty quickly. If you want to get both dual HLS and dash, you can work on that where you take your input, you're going to do your MP4 fragments, that will give you your actual MP4 fragments, that will then be used for both of them, and then you do an MP4 dash, specify also HLS, no split, use segment timeline, output, and the key thing here is the no split will output M4S segments. Here's an example showing what it'll look like. It also usually puts another EXT tag letting you know that this was actually done with Bento as well. But the idea here is that it will kind of put everything together for you relatively quickly. We don't have to worry about manually generating master manifests, and it has a whole bunch of really cool features and is really actively being developed right now. It's all open source free, similar to FFMPEG. You can go and get that. One key thing to note is Bento will only work on work around iframes for managing your segments and so forth. If you need to do adjustments to your segmentation, and you want to adjust those iframes, you have to do that prior to giving it to Bento. So, we will sometimes have to do a pass with FFmpeg, say, hey, we need you to add additional iframes at whatever interval that we want. If we're going to be doing a low latency and we need to do small segments, if we didn't already have something at that level, then we'd go ahead and do that, and we can use that. After that, we can then go back to Bento for our splitting. Generally works a lot faster than FFmpeg or Shaka Packager. We did a pretty good analysis on FFmpeg, Shaka, and Bento for some of these type of features for one of our big projects recently, and Bento definitely was the shining winner. Shaka is like, well, it could be really cool, it's close to really cool, but oh my god, it's a pain in the butt. And if you have more questions on that, you can ask Phil over here who works for us and how to do all that kind of digging through afterwards. Another nice thing it does is it'll gather up the metadata while it's segmenting, so codecs, average bandwidth, and resolution are automatically added to all the manifests for us, which is really nice, and also a full set of dash and metadata options. So there's a tiny bit on Bento. In the application that we're going to show you guys and that we give you guys all the source to, we can use both FFmpeg and Bento in there, so you can see how that kind of works together. Now when we actually start talking about, hey, cool, I have a bunch of content, or I don't have content too often, but when I do have it, I need to be able to get this stuff encoded. I want to be able to have a system in place, some type of preferably cloud or on-premise that also maybe publishes out to the cloud, a solution that I can scale if I ever need to. What are the things that we need to actually start thinking about when we're putting that together? So, first off, well, okay, where do we want this to live? Is it going to be on the cloud? Which cloud provider are we going to do? Or is it going to be on-premise? Or is it going to be combination? Like I said, that, hey, I want to be able to just run something on machines in my office, but I want to push all the assets all the way up to S3. The sample we have can work in either way. You can just deploy the whole thing to cloud, or you can have it on-prem, and you can then set up your storage remotely as well, and it can just push to there. But all these things are considerations you need to think about up front. Sizing stuff. Okay, well, the whole concept of, hey, I want to know how long it's going to take to be able to process this library. You need to understand what your content is, what your output is, what the hardware you're running on is. All that's going to come together. If you're talking about sizing for live, what's going to be your concurrent streams? What's our rendition ladder going to look like? Gathering up this information will help you guys get a good feel for what you need to do when it actually comes down to sizing out either servers or time that's going to take for processing this stuff. And none of that has usually simple, direct answers. It's kind of details into what exactly you have going on and what do you want to require. And then from there you can determine what's your scale. to give you some guidelines, we did some stuff a year or two ago, and actually the project's still running, where our client really wanted us to evaluate just from a cost-benefit perspective of some of the instances and what it could do when it came to having to process just a ton of video 24/7. And we found actually that the M3 large at AWS were a really good bang for the buck. They aren't the most powerful by far. You can have crazy big systems there. They have no GPU level either. But when we compare those even with the GPU stuff, we saw the GPUs had killer performance, but they were about 4x the price. When we were able to get actually dollar to dollar, even though it took a lot longer, it was cheaper to have more other instances than it was some of the GPU instances. So once again, it kind of depends, and trade-off is what's going to be quicker, what's going to be more cost-effective, and where to kind of go with that. But this was some of the stuff that we had to deal with and figuring out. And we definitely lean towards using Linux-based, keep the overhead light on the system, and just let it use as much resources as it can for the encoding. There's some interesting stuff when it comes to also HEVC. When you do look at getting into there, we'll talk a little bit about that. I think here coming up pretty soon, I'll make some notes on it for you guys. Didn't look like a whole lot of people are doing HEVC yet, but I can probably presume that most of you guys will be thinking about that in the next year or two, especially as broader spectrum support for playback starts to come to fruition, hopefully. And we'll see how that actually plays out. A couple links if you guys end up needing them to getting started on actually setting this stuff up in the cloud. We're not going to worry about that for right now. As I mentioned, there is GPU support right within FFmpeg that you can do. You have to make sure you get the appropriate builds, and they can be a little bit harder to configure. But to have hardware that supports that becomes more challenged. If you're having on-premise hardware, it's actually a lot easier to find hardware that's going to support that. You can get way good benefit off of utilizing that GPU for your encoding. And a lot of that stuff actually will happen even out of the default builds with FFmpeg. For deploying stuff on cloud, it becomes a little more challenged. You do need to actually make sure that you find ones that have appropriate GPU hardware acceleration enabled. And then sometimes you'll have to worry about getting appropriate compiling builds for your FFmpeg or otherwise that will leverage that, but you can see really impressive improvements in encoding, although it does come at a pretty penny. So this is where you might want to consider, like, well, do we need this up 24/7? Is it as needed? Or if it is 24/7, great, but make sure you're using it appropriately. And you can cross-compare that to, well, okay, what's in the price for others? I did mention HEVC. HEVC is really cool. Small files, great quality, all this great stuff. Not a whole lot can play back right now. Apple's primarily. Also, Edge can do some when there's hardware acceleration behind it. Problem is it's really slow to make HEVC files for the most part. It's super powerful, and the X265 codec is really amazing. I mean, honestly, it's just impressive how it can apply and what it can achieve. But it is just slow as dirt right now. That's changing as hardware improves. Big thing is some of the new Intel scalable processor families actually has a huge benefit push on that. And it all has to do with how parallel threading can work with the encoders. They normally tap out really low on the parallel threading, but some of the new CPUs are actually really helping on that to start. Azure just released the fact that they have some of the new Intel scalable architecture systems available, and Amazon said they were about a year ago. They probably will really soon now actually get that up there. They are going to be on the very, very large systems. They're like this 32 core systems or something like that, or 32 or 70. They're big, they're expensive, but oh man, you can throw some video at it. And with those much larger systems and that new CPU architecture, that's where you can actually do things like 4K live transcoding of HEVC. So it is possible, but you have to have tuned hardware for it. Kind of the stack that we usually end up kind of working with when we're talking about putting together some kind of quick little cloud and code system. Obviously, we're using FFmpeg, Bento 4. We use ImageMagick. We do a lot of stuff oftentimes that we need, like sprite sheets and thumbnails. We do that oftentimes over using the iframe tracks. It can perform a lot better on the client side, depending on what you're doing. We build out a lot of solutions with Node.js. This is where you trade off the benefit of ease of development and development and maintenance with less infrastructure and some of the challenges that you might have to have with keeping your processes running all the time and so forth, but they can have a good trade-off for us. The heavy lifting is all going to be done via things like FFmpeg and our libraries, So we don't have to worry about the potential inherent slowness, oftentimes, of running something in Node from a logic layer, because it's just kind of being an orchestrator. It doesn't have to do much. And it makes it very easy to develop, to drive down that cost, and also time to market versus utilizing some of the other stuff. And then, really, it's any type of database that we need that might be used for persistence, and most all of the primary cloud providers have some kind of cool SDKs for integration with their systems. We can download this. So pretty easy if you do have a remote system, cloud-based, you can still install things like FFmpeg really quickly. Can all be done just from the command line, giving you some references so you can see how it happens. A key thing if you are going to be putting together an actual service or solution is think about what your workflow is going to be like. So there are workflow systems you can actually integrate directly with if you want to, like AWS Simple Workflow. We ended up, originally when we were doing a big project for a customer, we looked at using that, but the challenge and reason we didn't is that essentially marries us to that cloud provider. If we want to go to another one, we have to start largely from over and then work with their system. So we wanted to take a look at what they kind of do in theirs, as well as what we might want from ours, and come up with a system that works well. We've broken ours out, generally speaking, into 4 main areas. We have workflow, steps, tasks, and adapters. Workflow is the end-to-end execution. Steps would be things like ingestion, processing, transfer, and tasks, creating alter-bit render additions, thumbnails, and so forth. And then adapters. We have this to be so we can really be agnostic. So we can have a Amazon S3 adapter, or an Azure Blob adapter, or an on-prem file management adapter. And we're able to leverage it in that way. In the end, we actually are making it so we can just set up an XML file or a JSON file that specifies a whole workflow for us and feed it to the system. One key thing to do when you think about transferring, if you are going to be working with cloud, is there are ways that you can help try to enhance or optimize what you're transferring and what it's going to be able to do. Things like multi-pid upload or Azure streaming with a putter blog. You can take that stuff further as to, okay, great, I have these very large files that need transcode. I want to be able to start transcoding those before the whole file is completely delivered. So I want to be able to do that from a stream perspective. Those are ways that you can take things a little bit further as well. Or also, initial content migration. This is a big challenge we've run into with a lot of customers is that, okay, great, we want to set this whole system, but our initial ingest, we have 100 terabytes. Well, I'm not going to upload that from my office. How can you deal with that type of stuff? There are services or devices and stuff that you can get from some of the suppliers, from the cloud providers that will help expedite some of that as well. Another key element is also queuing. If you're actually going to be building out something other than just, hey, I want to be able to do one file at a time, you really need to think through a good queue system. So what we can do to line things up, how are we going to distribute it? Making sure that you have some persistence along that as well is going to be key. You would never want it that, great, there's a bunch of stuff that needs to get encoded. Oh, crap, it crashed. Okay, cool. It should be able to reboot and just resume from where it was. Worst case, you should have to restart the individual file it was working on, but it shouldn't lose what it needs to do next. So, like I said, we put together a nice, cool demo for you guys. It actually gives a good kind of initial starting point if you want to mess around and start building out one. It's going to be here up on GitHub. And I think it's up now? Yeah, it's up right now. We did a big update from last year on there, too. It now has HEVC encoding in there, and now uses also Bento instead of just FFmpeg. It's all written in TypeScript. So even though, like I said, we like using Node.js, so it's more JavaScript-based, we do all our development in TypeScript. Gives it a little bit more structure and a little bit more options for what we might be able to do down the road with it as well from a maintenance maintainability perspective. Before we dive into the demos, a couple things just to kind of talk about. Scaling, concurrency is one of them. Keep in mind when you're working with FFmpeg, if you're going to be using this to try to do a lot with it, FFmpeg won't error out if the CPU is busy. It just takes longer to process. So that means if I have 100 jobs, I could tell it to start encoding 100 different things at the same time. Probably not the greatest idea. It's once again depending a bit on your hardware, but even then, I probably would never go that high. We might say, hey, you can encode 4 or 10 things concurrently, but if I have 100, I'm going to set up a line and then start processing those as we come in. Things like setting up priorities become really good for that. Like, hey, I might have a job that comes in that this is really important. I need this done right now. The CEO got to see that. Versus, okay, this can happen later on. So setting up priority that you can also have things that jump the queue and stuff like that or go lower and it's going to be really good. And go from there. when you're determining how much you need or what you're going to go, you need to think about what your output's going to be and how long your average job takes on the hardware that you're running. How you're going to deal with that is you can always get bigger instances. That's one of the nice things about cloud. It's like, okay, well, we know we're going to have a larger volume. We can up our instances so we have more processing power. But keep in mind, sometimes just throwing more processing power doesn't always leverage as much as you'd want, making things faster. You might be able to do more, but not faster. Part of that comes down to how well it does parallel within the actual threading. Or you can also do more instances. So, hey, great, well, we've seen that it's actually cheaper just to spin up more instances than instead of upping our instances with what we actually get in our throughput. So we'll just crank on some more instances, at least temporarily, and go from there. Down there is that it can be more complicated to manage. So when it comes to scaling beyond that, I'm going to kind of zip through this stuff. I mean, ultimately, you can use either a load balancer, and then you can determine who you want to go to. The key thing, though, that we do think is real important when we started building out this type of stuff is that whatever we build, we want to be self-contained. Right? We want to be able to run multiple instances of this without them interfering or requiring anything from each other. At most, there can be a top-level one that shoots off who's going to do what. We're not talking about grid encoding here. So having a way that we can deploy multiple instances and have this stuff go very quickly becomes really powerful to us. And then we can really leverage also solutions from the cloud, like auto-scaling and elastic capabilities there. Dockers, and creating swarms of Dockers, that's kind of a newer DevOps type of realm that allows us to do things kind of like I think of it almost like a next generation of virtual machines. Docker containers are going to be able to have better utilization of the system resources. Still in a dynamic way that you can create more of them, but it's not going to be as rigid in some ways as VMs. We can talk more about that if anyone has any questions. So I want to turn this over to June, let him actually show you guys this little demo encoder that we have available to you guys. And if we have some time, we'll show the manifest viewer as well. And we can also answer any questions. Go for it, June.
I'm June. Feel free to stand up and stretch. You can watch standing up. I'm not going to get mad or anything.
No stretching.
Oh, I thought it said 245.
Oh, does it?
Yeah.
Okay, cool.
What? Oh, this app is wrong.
Then we're out of time.
Okay.
All right, quick demo then.
All right, well, really quick demo. No stretching, sorry about that. The app says 245. I'm going to just show you this real quick. So this is an app. I have it running locally on my machine. It's built in Node.js utilizing TypeScript. Right now, it's kind of hard to see. It's on port 3000. It's listening for any kind of request. So if I come to the demo encoder, which we've made available through GitHub, I can select a number of bit rates. So I could say, hey, I want 3 different renditions here. And then in addition to that, I would like to do x.264, or I could do 265 as well. I can select the segment size if I want to. And then I could just generate the MP4 files, or I can say, hey, I want the M3U8s. So we keep talking about FFMPEG versus Bento. When I'm doing Bento, that's M3U8. And then if I just select MP4, that's FFmpeg, because that's what those 2 tools are really good for. So I'm going to grab a video off my system. And I can preview it and stuff if I want to. And then I'll just go ahead and click Submit. At this point, you can see that it's encoding some videos here. And we'll let that chug away. While we wait for that to happen, I'm going to grab a link here. Hopefully it's still online. We built a tool as well that we utilize to diagnose things. We will be making this available to the public soon. It's called the manifest viewer. So I can type in an M3U8 in here, a manifest file. I can say to show the video, mute the video, display metrics. I could use a proxy. I can set credentials in case there's some kind of token auth. And then I can pull it if it's a live manifest. So the nice thing is this supports VOD and live. If I go to click to load the manifest, so the set level manifest will show up here on the left-hand side. The video will start playing back in this video player. And not only that, but I have some metrics down here at the bottom that shows which of the bitrate renditions it selected. If I look at the manifest, I can actually say, you know what, instead of that, I want to select this other bitrate rendition. And at that point, it's actually going to change it. And these metrics will kind of update as I kind of go through here. The other thing you'll notice is on the stream level side, you can see the stream level manifest that we've selected. it shows what segments are available, and it also does a load and verify as well. So if it's green, it means that it's a good segment. I can even use this to kind of navigate through the video and navigate back and forth. So if we look at the timeline here, I'm there, I click there. So I can seek through and place specific segments in here as well. Do you want to add some more to this?
No.
So it's a really cool tool. Demo encoder. For some reason, it wasn't listening. Oh, there he goes. That's what happened. So what we can see here is it created 3 streams, so 3 bitrate renditions. From there, it generated a bunch of manifest files. If I look in this output folder here, I can see that I have my original file, and then I have some output, which includes 3 different bitrate renditions, and finally the HLS assets, such as the M3U8 files. I can have it create iframe playlists. I can have it create an audio-only playlist, et cetera, et cetera. So that's leveraging FFMPEG and Bento and some custom logic to build your own encoder.
And then it also puts it up to S3.
Yeah. So here's the links real quick. So one last thing, and then we'll probably have to. It provides the links. I can take one of these guys here, this guy right here, and I can go back to my manifest viewer and get that. And it just loaded in the manifest here, and then I could play different bitrate renditions. So
that's it. We went over. If you guys have any questions, we'll be headed towards the back of the room as we get booted. Thank you guys so much for coming.